Now we're gonna be adding this thing right here, which is gonna be this crazy. What is that? What does this thing do?
Not for me. Superconductor.
So we're going from the power supply here positive. We're taking that into the MA piece of the ammeter, coming from the COM, plugging that into this little resistor over here, taking that, going all the way into the galvanometer over here. Now we moved it super far away, as far as possible from the power supply that we could, and we made a little extension that we're going to plug it right into the negative port. Now we've got this other little thing here, the dip needle, that we're going to line up parallel. We can kind of double check that this is in the right zone by sort of just lining it up with the compass like that. So once we've lined up these two things like this and like that, we're now going to twist the little protractor and make it perpendicular to the table.
The current takes a bit to disperse. It was doing that before.
Measure the dip angle here, and as you can see, it's pretty dang inclined there. All right, let's go and turn the power supply on and see what happens. Whoa. All right, now we're gonna try to adjust this until it is 45 degrees from north. So we had to twist the voltage to about 1.6 or so to get that 45 degree angle, and the current was 131.6 milliamps. So with these measurements, we were able to sort of calculate the magnetic field, and we were pretty close to what it's actually supposed to be. So we got about a 10% error from our calculation. Now we're switching this from the 400 milliamps to the 10 amps over here. We're plugging SF38 into the main unit over here. So we put the magnet on the scale, and then we lowered that piece into the magnet. Now we're setting this thing. This is a rheostat. We're gonna put this thing in the middle. So it's the whole thing is 5.6 ohms, and about here is about 2.5. So we created a little loop. We were starting here with our power supply. We're gonna plug that into our ammeter thing, and then we've got this special resistor thing, and then we've got this big scale contraption, and we're plugging that back into the power supply. Making sure this is on DC, we're gonna adjust this to 1 amp by changing the power supply voltage. Pretty good. Once we got our current at 1 amp, we got a scale reading of 0.36 grams from our magnets. We're just gonna repeat this experiment by going to 2, and then 3, and then 4 amps. So let's just see what happens. Well, by keeping the wire loop the same, but by changing the currents, as you can see, we were able to get a magnetic field of 82 milliteslas. We're gonna pull out SF38, and we're gonna replace it with SF39. We set our current back to 2, and we got a reading of 0.53. So now we're gonna replace that stuff with this 37 one. This is the new one, 37. Just had to adjust that current slightly, and now we've got a reading of 0.36 grams. The final one we're using is gonna be SF40. Bam. So we got the next one set to 2 and a reading of 0.19. This time, by keeping the current the same and changing out those wire loops, we actually were able to calculate that field from the same magnets at 81 milliteslas. So we're pretty close to the previous one. Now we're going to be adding this thing right here, which is going to be this crazy... What is that? What does this thing do?
Not for me. Superconductor.
We lined it all up properly, and now we're going to tear it. There we go. Beautiful setup. We're going to try to get this current to about 1.8. So now that we have this kind of teared to 0 on this red thing, we're going to line it up to all these different angles that are on our paper and get some readings. Let's go and switch that to positive 15 real quick. And here we go. So since we're getting a negative reading here, we're going to assume this is a negative 15 degrees. We got a reading of negative 0.41 at around negative 30 degrees. So we were able to take all those readings and create a graph and calculate the slope. And from there, we were able to calculate the magnetic field.